for his testimony on climate change to Congress in the 1980s that helped raise broad awareness of the global warming issue. Dr. Hansen was elected to the U.S. National Academy of Sciences in 1995, and he was designated by Time magazine as one of the world's 100 most influential people. That was in 2006. Also in 2006, the American Association of the Advancement of Science selected him to receive their award for scientific freedom and responsibility for his courageous and steadfast advocacy in support of scientists' responsibilities to communicate their scientific opinions and findings openly and honestly on matters of public importance. In 2009, Dr. Hansen was awarded the Carl Gustav Rosby Research Medal, the highest honor bestowed by the American Meteorological Society, for his, quote, outstanding contributions to climate modeling, understanding climate change forcings and sensitivities, and for clear communication of climate science in the public arena. The title of Dr. Hansen's address today is, quote, Threat of Climate Disruptions, Implications for Energy Policy and Intergenerational Justice. He will be speaking as a private citizen, not as a government employee, and following his address, he's delighted to take questions from legislators and then from the general public. Following that, we hope Dr. Hansen will also be available to the press. I hope all of you will join me in an enthusiastic welcome to Dr. James Hansen.
Thanks very much. Thank you. Thanks very much for this opportunity to speak with you. And you can see that I changed the title of my talk a little bit, preparing this yesterday. The coal issue is extremely urgent, and I hope to make that clear to you. I always need to start out by pointing out that there is a gap between what is understood about the global climate change issue, global warming, by the relevant scientific community, and what is known by the people who need to know, and that's legislatures and the public and policymakers. Because the truth is, it's hard for people to recognize that we have an emergency, but we have reached a crisis point, which is particularly important for our children and grandchildren. But the reason that it's hard to recognize because weather fluctuations are much larger than global warming is at this time. And yet, it is extremely important because of the inertia of the climate system. We have only experienced a fraction of the ultimate climate change due to the gases that we've already added to the atmosphere. So there's more in the pipeline. And we can push the climate system to points where the dynamics begins to take over and changes begin to occur that are out of our control. That's the danger. And the bad news is that it's become clear that the dangerous amount of carbon dioxide is no more than 350 parts per million, and we've already reached a level of about 385 parts per million. We can still get back to a safe level, and there would be many benefits in doing that, but it requires us to begin to take actions very promptly. This graph shows the global temperature change over the last century. The temperature has increased by about 0.8 of a degree Celsius, which is about 1.5 degrees Fahrenheit, and most of that warming has come in the last 30 years. Last year, 2008, was the coolest year that we've had since the year 2000. But that is a temporary fluctuation which is associated with the temperatures in the tropical Pacific Ocean. This red and blue diagram at the bottom of this chart shows what's called the El Nino index. When it's red, that's warm period El Nino. This is describing the southern oscillation, the natural fluctuations from El Ninos to La Ninas, where La Ninas are the cool phase and El Ninos are the warm phase. It's associated with upwelling of deep water in the Pacific Ocean. So the last 2 years we've been in a rather strong La Nina, which is the reason for the low temperature last year. The blue line is the global ocean surface temperature, and as you can see, there's a very high correlation between El Ninos and warm global temperatures and La Ninas and cool temperatures. So that's the reason for last year being cool. But as I say, the warming is small compared to weather fluctuations, but if you average the temperature over several years, then you can see the warming effect very clearly. The map on the right shows the temperature anomalies in the first 7 years of this century relative to the period 1951 to 1980. And yellows and reds are warmer than that long-term average. And you can see that it was warmer than the long-term average essentially everywhere, with the warming larger over land than it is over the ocean. Because the ocean has this thermal inertia, it's only partially responded to the changes in atmospheric composition. The warming is larger at high latitudes and low latitudes because there are feedbacks at high latitudes. As ice and snow melt, it exposes a darker surface, and that magnifies the warming. And the map on the left was 2008, and you can see that the Pacific Ocean in the low latitudes was cool, but other places it was just as warm or warmer than it was in the preceding 7 years. Nevertheless, you can ask the question, why should we be concerned about global warming? Because there have been much larger temperature changes in the Earth's history. That's true. But I think I can make clear why this is important. And the basis for our understanding is, first of all, looking at the history of the Earth, how the Earth's climate responded in the past when there were changes in boundary conditions such as atmospheric composition, and also looking at the changes that are occurring now as humans are changing the atmospheric composition. And also climate models are helpful, although I would put them number 3 on that list. And because the history of the Earth is so important, I need to show you a couple of charts on the Earth's history. This shows the temperature, happens to be the temperature in Antarctica, obtained over the last 400,000 years with time running from left to right. You can see the amplitude of these temperature changes is about 10 degrees Celsius, which is about almost 20 degrees Fahrenheit. So there are large climate changes that occur. This temperature record, by the way, is obtained by drilling a core through this ice sheet. Antarctica and Greenland are covered by ice sheets that build up as snowfall piles up year after year and gets compressed into ice. And from the isotopic composition of that ice, we can tell the temperature at which the snowflakes formed that then formed the ice sheet. And also, as the snow compresses into ice, it traps bubbles of air, so we can sample the Earth's atmospheric composition over this entire time period. And in any case, the climate goes through these cycles, which are big climate changes. We live now in the Holocene, which almost 12,000 years long now, we've been in this interglacial period, a relatively warm period. But these fluctuations are instigated by changes in the Earth's orbit. The Earth's orbit is perturbed mainly by Jupiter and Saturn because they're the heavy planets, and they cause the Earth's orbit to change from nearly circular to slightly elliptical, and they cause the tilt of the Earth's spin axis to wobble by plus or minus 1 degree.